Hello there. Here I'm going to explain the abstract of this project. So the project goal here is to develop a 3-speed fan and light controller using a easy 68K simulator, enhancing microprocessor teaching at UTEM. So our motivation here is to reduce fan noise and energy consumption, combine control for space efficiency and user convenience, provide a practical PBL project for the microprocessor course. So the technical overview is utilize the Motorola 68K microprocessor architecture, which is released in 1979. Secondly, is features 32-bit register and instruction, 16-bit data bus, and ALUs. ALU. And the final one is the system design will be compared to alternative option. So that's all for the abstract. The next one is the problem statement of this project. So the user problem here is the fan speed, because the fan speed is too limited and too slow for the user or lacks a variable setting speed to adjust the airflow to the user's requirement. Secondly is the space problem, which is lacks space to accommodate both a lamp and a fan in the same location. The final one is the compatibility. Some software is not compatible with the specific switch and sensor used on a fan and light, and it can be a complex programming to make a program and increasing the development time to make and the cost of this project. So that's all for the problem statement.
Okay, hello. So moving on to the next one, which is the introduction for our project. So in our project, there actually are three simple tools that we use, which is the first one is actually the fan controller, the second one is the lamp controller, and the last one is the microprocessor. So these are the three simple tools that in our project use. So moving on to the next one, which is the objective for our project. So our project, the first objective is it's design and build a light fan with user control speed, and then the second objective for our project is to gain practical experience in terms of hardware deployment, device coding, and the last one is the easy 68K simulation. So these are the objective for our project. Okay, after that we're moving on to the methodology. So in this methodology, I'm going to tell you all about the project overview, the key feature, the testing and validation, and the conclusion for our project. So let's go to the project overview. So project overview for our project is actually to design a compact ceiling fan with integrated lamp, and then to utilize easy 68K for coding and testing on hardware. And then the last one is to control via 5 buttons on 3 fan speed and 2 lamp. And then the next one is for the key feature for our project. So our project, there are several key features, which is the first one is actually for space saving. So this one is actually to eliminate the needs for separate fan and lamp installation. And then the second one is the efficiency ventilation, which is it provides strong air circulation. And then the last one is the convenient lighting, which is it integrate lamps, illuminate the room. So moving on to the third one, which is the testing and validation. So in testing and validation, we actually use easy 68K platform to facilitate easy coding testing and hardware integration. And then it testing using 7-segment display and button and LEDs. So the conclusion for our methodology is actually to innovate ceiling fan design combine functionality with space efficiency, and then it's offer a practical solution for improved air circulation and lighting. So that is the methodology for our project.
Next one is the flowchart system of this project. So a flowchart is a type of a diagram that represents a workflow or a process. It is a diagrammatic representation of an algorithm, a step-by-step approach to solving a task. The flowchart shows shows the step as boxes of various kind and their order by connecting the boxes with arrows. So the project start with the start button, and when the switch press, the condition will be displayed on, whether it's on or whether it's off. Next, when we press the button 1, the speed will be low speed, and the button 2, it will become the medium speed, and the button 3, it will become the high speed. After that, if we push the button 5, it will turn on the lamp 1, and if we push the button 7, it will turn on the lamp 2, and that's when the programming will stop and it will come back to a condition to display on. That's all for the flowchart of this project.
Okay, Assalamualaikum and hi. My name is Muhammad FARIS bin ZAIDI. Now I will explain about our coding. Okay, firstly is for declaration part. Okay, as you can see, this 7 address is for 7 segment. Okay, this address for turn and this address for LED. Okay, next for assign initial condition. Okay, we use move.b h1 d0 move.w h1 d1 until d4. Okay, for the main loop decision making part, this is the main coding or address for our project. Okay, for the main loop we use move.b d0 LED. Next we use cmp.b for turn at d1. For turn d1 is to command for turn up. Then for h00 turn for turn off. For turn d2 command for speed 1. For turn d3 for speed 2. For speed 2. For turn d4 for speed 3. Then for and the rest is command or for the light. Okay, next for turn up and turn off subroutine. Okay, this command, this coding is for display monitor for turn up. Okay, this coding for display monitor for turn off. Okay, then this coding for display monitor for speed 1, speed 2, speed 3. Okay, for light subroutine, this command or coding for light. This coding for light 1. Okay, lastly is data manipulation part for speed. Okay, as you can see, there are 3 different speed, which is fast, faster, and fastest. Okay, for the fast, we use $9000. For the faster, we use $5000. For the fastest, we use $3000. Okay, based on 3 value speed, we can know the value is decreased, which means that smaller value that we use in address, the rate of speed will be increased. Okay, that's all for our coding. Okay, now I will explain about our group hardware simulation. Okay, firstly we need to run simulation. view hardware. Okay. Firstly, I will explain the switch that we use on our project. To turn on hardware, we need to press button 0. Then monitor will show turn on. Okay, to adjust speed, we can use button 1, button 2, and button 3. Then to adjust light, we can use button 5 and button 7. Okay, next I will press button 1. Then we can see monitor display speed 1 and LED will move slowly. Okay, if we press button 2, LED will move more faster than button 1. Okay, next, if I press button 3, LED will move faster. Okay, after that, I will show how to turn on light. If we want to turn on light, we need to press one of button speed. Okay, for example, if I will press button 1, then press button 5. Okay, as we can see, all LED will turn on and maintain, and monitor will display light 1 and speed 1. Okay, then if we want to change another option light, we need to turn off button 5, then press button 7. Okay, as we can see, all LED will turn on and blinking. Okay, same goes to another speed. We can use the same step. Firstly, okay, for second example, we use speed 2, and we will turn on light. Okay, you can see monitor display light 1, speed 2. Then after that, we can press button 7, LED will blinking and monitor display light 2, speed 2. Okay, for example 3, we need to press button 3 and press button light 5, and we can see monitor display light 1, speed 3, and LED will turn on and maintain. Then if we press button 7, LED will blinking and monitor will display light 2, speed 3. Okay, that's all from our hardware simulation. Thank you.
Okay, hello. You are at the end of the video. So before the video ends, so I'm going to tell you the conclusion for our project. So in our project, we're using EZ68K to build a ceiling fan with an integrated lamp, simply combining key microprocessor component. So it's to optimize for user experience. Both fan speed and light mode can be adjusted with a single command. So for future growth in our project, we consider this potential enhancement, which is the first one is the smart automation, and then the second one is the remote control. The third one is actually you can control this device by using mobile apps, and then the fourth one is feedback display. So there's a feedback display inside of the product and in the project, and then the last one is actually energy efficiency option. So you can usually use electrical more efficient by using if this option is in the project. So this project bring the gap between coding and practical application. So demonstrating the power of microprocessor in building innovation and user, it's a friendly system. So that's conclude for our project. Thank you.